Hi, Uriel.
Hey,
How's it going?
pretty good. How about you?
Good. Yeah, just waiting for my COVID test. They it's taking longer than I thought. But so I thought I was hoping to be back today, but actually my cough's gotten a little bit worse today, so maybe it's good I stayed home.
Yeah, that's good. At least you get to relax at home, though. You don't have to deal with traffic.
Yep, that is true. That is true. That's one nice thing about working from home.
Yeah.
Professor.
Hey Jacob, how's it going?
Hi. Good. How are you doing?
I'm okay. Yeah, my cough got a little bit worse today, but
Okay.
yeah, so still staying home.
Are these lecture slides always going to be posted on the course page after each lecture?
Yes. So actually, they'll be up a week before, and so I'm going to give you a tour of the course website today because we didn't get a chance to do that last time, And so usually I'll have stuff up like the weekend before, of the upcoming week. So you can look at the notes before the lecture.
Okay, cool. And in terms of like lecture speed, would you recommend maybe, because I like to handwrite my notes, would you recommend taking notes before class and then just writing down the extra stuff, that you maybe fill in terms of like math examples and stuff like that? Or would you say it's an okay speed that I'll be able to write everything down?
Oh yeah, I mean, if you have time for it, I mean, I think that's always going to be beneficial, because it's hard. I think it's always hard for people to listen and kind of write at the same time. But I do try to stop during my lectures, to give people time to write, give people time to ask questions during the lectures too. And so if you can do it, I think it can only help. But I do account for the fact that people are writing. Last time and this time a little bit too, I might be going a little bit fast just because it is lecture slides. But usually my preferred form of giving lectures is to write on the board or to write on an iPad. And so just naturally, because it takes me time to write some stuff. And so I think it kind of naturally slows me down a little bit too.
Yeah, the screen sharing iPad, it's much easier to handwrite notes that way for sure.
Yeah, definitely.
Okay, cool. Alrighty. Thanks, Professor.
Yep. All right, it's 4 o'clock, so let's go ahead and get started. All right, good afternoon, everyone. Thank you guys for meeting again virtually. I know it's not what we expected for the first week, but I think you cannot be too cautious under these times. So yeah, my cough got a little bit worse today, and so I think it's better that I stayed home. But I still waiting for the test just to make sure. So and so I'll update you guys when I get that. So. But welcome, so this is our second lecture for EGME 441. And so how's everyone doing today?
Doing pretty good. How are you?
Good. Yeah, I mean, just worried I got COVID, but besides that, just doing everything I can. Right. Okay, so the plan for today is we didn't get a chance to tour the course website last time, and so I want to make sure I do that. Just because I know every instructor kind of sets up their website a little bit differently, and so I always find that it's useful to just give a quick tour, just so that you guys can see kind of how I've set things up and where you can expect to see things. Right? And after that, we have another set of lecture slides today, and so the topic for today is anatomy. And so today it's going to be a lot of vocabulary, and so I think this might be one of the more disorienting days this semester, because it's we're going to be learning a lot of new terms, that we need to use to refer to all the different body parts. So I know that today is going to be a lot, and so if you feel like it's hard to kind of remember all these terms, don't worry about it. It's even I'm still learning these terms even years after I learned these. So I think it's the thing with like any kind of vocabulary and any kind of terminology. It's you kind of have to do a little bit of shock therapy, where you kind of have to be exposed to a lot of it at once. And then as you use it more and as you kind of look stuff up and as the semester goes, you become a little bit more and more familiar with it. Okay. All right. And so here's all the learning objectives for today. And so it's quite a lot, because there's quite a lot of terms and quite a lot of concepts to know. And so, I'm gonna the goal is to try to get through everything, but we'll see how we do. Okay. All right, and so with that, let me show you the course website. And so this is the Canvas site that we've been using. Okay, and so if you go to the home page for the Canvas site, you'll be greeted with this page right here. Okay, and you can see from this page we have the title of the class. We have my my basic contact information. Okay, you have my email address. You can actually click this. And this kind of shows like my Tinder profile for teaching, if you're interested in reading that. Okay. Here's all the lecture times. Here's the location for the class, which is obviously not we're not there right now. But once we start going back in person, that's where we're going to be, in the E201 lab. Okay. Here we have the course description, and so this is what I've written up for the class. The learning objectives for the course. Okay. And then I think here are kind of the more interesting things. And so here we have the syllabus. And so you can go ahead and click this, and you can view the syllabus. And so we went over this last time, but you can, download it and keep it for your own reference. Okay. we have each of the Zoom links for the office hours. Okay, and so if you want to come to office hours and you want to do it virtually, you can do it through these links. And so all you have to do is click on these links, and then it'll open up a new Zoom call where you can talk to me. Okay, all right. So I have no more office hours for this week, but my next office hours will be beginning of next week, right? And if you want to join the Discord server, you can do that by clicking on this link here. And so I know a lot of you guys have already joined the Discord server, so thank you guys for doing that. But if you're interested in joining, you can do that here from the homepage. And so all you have to do is click this link, and if you have a Discord account, it'll automatically link your Discord account with this server, and then you'll be able to get all the messages there. Okay. And so usually, I won't use the Discord server too much for making announcements. And so any announcements I'll make through Canvas, because I know not everyone's going to join the Discord server, but definitely use that. Meet your classmates. Ask questions on there. I think it's a nice place to go just to interact with people. Okay. All right. And so that's the homepage. But I think where you're going to spend most of your time on the course website is from this section down here, which is the course outline. Okay, and so you can see here I've outlined the 16 weeks of this semester. Okay, and then as we get along in the semester, each of these weeks here will become clickable, right? And so if you go to week one is already done for you. And so if you go to week 1, you can see generally what information you can expect for each week. Okay. And so for each week, we have the title of the topics we're going to cover that week. We have a short description of what you can expect to learn. Okay, and so here it's just a little blurb that I usually write up just to kind of introduce what we're going to learn that week. Okay, you have all the learning objectives for the week, and so you can read these and kind of get a more clear idea of what I want you to get out of the lecture content that week. Okay. And then down here, we have all of the other stuff, okay? And so first, we have the lecture recordings, okay? And so since I'm delivering these lectures over Zoom today, Monday and today, this is being recorded. And anything that I record, I'm gonna put up on YouTube, okay? And so you can find the links for that here. Actually, even though we're probably gonna start meeting in person soon, I plan on actually still using Zoom for those days too, okay? I need to figure out a good position for the camera, but I do plan on maybe bringing my laptop to the lectures and then kind of putting it in a space where you can kind of view the board and listen to me speak. Okay, because I've already had some students already come express their concerns with me that in case maybe you guys contract COVID, or maybe you have some concerns coming to class, you can still participate in the lecture. And you can still listen along, even virtually. Okay, and so I do plan on posting recordings here, but just keep in mind that once we start going back, it's going to be hard to get the camera to view the whole board well, and so if the Zoom things for that will mostly just for you to hear what I'm saying. Okay. But the good thing is that usually I follow my lecture notes pretty closely, and so I write the lecture notes in a way that I'm just going to go write down the lecture notes. And so even if you have to stay home and you're following along on the lecture notes, as long as you can hear what I can say and you have the lecture notes in front of you, I think hopefully that might be sufficient in order to keep up in the lectures. It's not ideal, of course, because you can't see the board, but I think it'll at least be something. Yeah. I bought a parking permit. Yes, I did. Yep. All right, and then after the lecture recordings here, you can see I have a section for assignments. Okay, and so anything that I assign, any homeworks, you can find the links to that here. Okay, and so if you click this link, it'll take you to this page. Okay, and so this assignment here doesn't have anything for you to submit because it's just to send me an email. But for future homework assignments where you can submit like your homework solutions, there will be a link to do that from here. Okay. Of course, if you want to submit your homeworks in person, that's totally fine with me too. But if you want to submit it online, then you can do that. Okay. And usually I make the homeworks due at 11:59 p.m. on the due date. And so if you can't turn it in the lecture or you're still working on it at home, you can keep working on it at home, scan it, and then just upload it to Canvas from there. Okay. Some people did the intro in Discord, so I'd still like you. I still like you to send me an email because the intro in Discord is more for you guys to kind of introduce yourselves to each other. But the email is kind of for me. Mostly just so that I have your emails on my quick complete or my autocomplete. Because if I have to contact you guys, it's kind of easy for me to just type in your name in Outlook and have your email there. And if you send me an email, then it kind of shows up automatically for that. Okay. And I think I think people tend to share a bit more when they're in a private email versus a public Discord server. Yeah. Okay. And so after the assignments, you can see that there's another section called files. Okay. And here's where I'm going to post all the lecture notes or the lecture slides, all the study guides, or any kind of document that I create for this class. You can download that here. Okay. And so all I have to do is click this, and then it'll download the file for you. Okay. All right, and so these weekly pages will be updated on Friday of the previous week. Okay, and so on Friday, what you can expect is that this week 2 entry here will be clickable, and then you can click that and you can view all of the learning objectives and the notes for the upcoming week. Okay. All right. So any questions on the course website so far? Okay. All right, and so that's the home page and all the weekly viewers, but you can see that there's other tabs here. Okay, and so the second tab here is for announcements. Okay, and so if you want to view any of the announcements that I've made for the class, you can view them here. Okay, whenever I make an announcement, it'll automatically send it to your email, and so this is just in case you wanted to view the announcement again if you want. Okay. All right, and so there's another tab here for assignments, and so any assignments that I have due will be in this tab. Okay, and here's kind of an easy place for you to submit if you don't want to go through the weekly viewer, and so you can click on assignments here. Okay, there's a tab here for your grade. Okay, and so if you want to check and see just a summary of all the scores that you've gotten for all the assignments so far, you can view them here. Okay, and you can see it's broken down between homeworks, midterms, and final projects. Okay. You can click on the People's tab, and so you can see all the people that are enrolled in this class, right? You can see their names, and I think if you click them, then you can view other information about them. Okay. Pages, don't worry about this. This is kind of just internal stuff, and so these are just the internal web pages that I manage, but you don't have to worry about this tab. And then the last one is files. And so here's kind of the file, kind of the Dropbox folder for this class, where you can see I've broken it down into different folders, right? And so if you're looking for a specific file, like maybe you're looking for certain lecture notes, you can just click on this files tab right here, and then go to lecture notes, and you can find this here, okay? And then I'm gonna have any files that I have for the project, any homework solutions or exam solutions, I'm gonna put here as well, okay? All right, and so that's the website, and so definitely keep updated with the website, because I do update it quite a bit, yeah, and then that's going to be your main way to kind of get information about the class. All right, so any questions on any final questions on the course website? Okay.
Sorry, Professor. So it's not about the website, but I have a different type of question. So
Sure.
What happens if one of us happens to either feel sick or test positive for COVID around the time of a midterm? Because another one of my professors is saying that she's just gonna scrap the midterm altogether, and then like 60% of your grade or something would be determined by the final only, and that's a lot of stress. So I'm just wondering what you would do in a situation like that.
Yeah, no, it's a good question. Yeah, definitely. If you're feeling sick or you test positive, definitely stay home. Don't come to class. But if it happens during a time of the exam, usually my policy is to give you a separate exam. And so, that will be something that we'll arrange kind of individually. And so if you are feeling sick and you don't think you can make it to the midterm time, please let me know as soon as possible. And then we can arrange for you to take a makeup exam, right? And so it's not going to be the same exam that everyone else takes. It'll be different, of course. But I usually like to do that because I usually don't like to just scrap those midterms. I think, like you said, it puts too much stress on everything else in the class. And so I like to give you an opportunity because, a lot of times, like a lot of times people have to miss midterm exams because of an emergency. And, a lot of times you've already spent some time studying for that. And so I think if I kind of just scrap that, it kind of throws all that work out the window. And, I don't want to do that. And so yeah, so please let me know if you feel like if you feel like you can't make it to an exam session, and we can work something out. Yeah.
Okay, thank you.
Yep. All right. Yep. So that's everything with the website. And so now we're gonna get into our lecture notes for today, which is on skeletal and muscle anatomy. Okay. And today we're just kind of introduce the concepts for these. We'll be diving a lot deeper into these as the semester goes along. But now I just want to get a lot of the terms and a lot of the concepts kind of into your head, so that once we kind of go over these in more detail later, you already kind of have a basic understanding for how these things. Because it's a lot. There's a lot to kind of learn about anatomy, and we're kind of doing like a SparkNotes speed run version of it. Yeah, parking is expensive. And actually recently they've been saying that they want to increase the parking prices too. That's what I've been hearing from the administration, and there's a big pushback for that. Yeah, especially from the faculty. Okay, so here's all the learning objectives for today. And so there's quite a lot, and so I'm not going to read through all of them, but definitely kind of keep these in mind. Okay. Okay, and so let's start. And so let's start just by simply defining, what is anatomy. Okay, and so anatomy is anatomy basically refers to the names of all the stuff, right? And so the human body is a very complex machine. You can even think of it as a machine, right? And so to refer to all the different parts of the body, we need to be able to have a consistent naming basis for it. Okay. And so when someone says anatomy, all they really mean is just the terminology for the different parts. Okay. And so this is essential because in order to study something, it's not just biomechanics, but anything in particular. We need to be able to accurately and consistently refer to the same things, using the same terms, right? And so if you think of like something like from your physics class, right? And so let's think of something benign, like something like velocity, right? And so if we had everyone calling velocity something different, it would be impossible to study it because everyone will be calling the same thing something different, right? And so kind of before you really start to analyze something, or anytime before you really start to learn something new, kind of learning the terminology and learning the language is kind of the first thing you should learn. Okay. That's not to say that we have to learn absolutely everything, because the thing with the human body and biologists in general is that they love super complicated words that make no sense at all, right? And so there's even I'm still struggling with learning a lot of the kind of very specific terminology that they use for stuff. But I think at the very least we have to kind of have a basic level of language that we need in order to actually start doing something useful with biomechanics. Okay. And so that's kind of the point of today's lecture, right? Is to kind of just start to get kind of the pure baseline, the simplest baseline of word that we can use to actually start doing useful stuff with biomechanics. Okay. Question. So does faculty pay? We don't pay. I think we pay a discounted price compared to you guys, but they do make us pay. Yeah. But they are nice, and so they automatically deduct it from our paycheck every month. So at least what a great service that they do for us. But yeah, they make us pay for parking. Yeah. Okay. And so the terminology, it can be a little bit intimidating because these words are going to be long and they're not simple, right? I don't know what it is with biologists, but they love super complicated words that I don't know, make them seem smart, right? And so it's going to take a lot of time. It's going to take a lot of practice to get used to all these words in their meanings, right? And I'd have to say that I think this is kind of the biggest barrier of entry for people. Engineering and people in the engineering community, of course, but anyone outside of biology, I think learning the terminology, I think, is kind of one of the biggest barriers to entry. And so it's going to be a lot today, but I think, like I said before, it's something that if you kind of keep at it and you kind of just kind of keep using the words and you kind of refer back to these lecture notes or refer back to the textbook, okay, that's what they mean by extension. That's what they mean by flexion and things like that. Then you'll start to kind of really start using the language. Okay. But just keep in mind that a lot of the nitty-gritty details and a lot of the more difficult words are going to come later in the semester. Okay. Okay. And so as a baseline, let's start with this idea or concept of whole body modeling or gross modeling. Okay. And so the idea with this is that, we're going to take the human body, which is, shown by this nice person here. Okay. And we're going to break it up into what I like to call the 17 major areas of the body. Okay. And so, those major areas are broken up according to these lines right here. Okay. But a kind of a more convenient way to draw it, because drawing a human is hard. A more convenient way is just to use ovals and circles and squares, right? And so this is kind of like the MS Paint version of a body, but you kind of understand that this represents the human body, right? And so each of these different shapes represents a different major segment of the body. Okay, right. And the reason we break this up is that, a lot of these break points are kind of where all the major joints in your body are, right? And so you can see we have a break here at the elbow joint. We have one here at the shoulder joint. We have ones at the knee, at the ankles, at the wrist. Okay. And then each of these segments kind of have their own distinct geometrical and anatomical features. Okay. And this is important because, if you want to describe things of like, where an injury is or what part of the body a device is designed for, you kind of have to start with, what segment of the body that you're talking about. Okay. All right. And so here are all the different names of the segments. Okay. And you can see in, and so it's a lot, but what you can see here is that, we start here with number 1. And so number 1 here is going to be the pelvis or the lower torso. Okay. Then we go up to the midriff or the mid torso, and then the chest area, which is the upper body torso. Okay. And you can see here that, a lot of these body segments kind of appear in groups of 3, right? And so we have the torso here, which has a lower, middle, and upper part. Okay. And if you look at each of the arms, you can see here that there's a lower, middle, and upper part. And same thing for the legs, right? And so we have a lower leg, which is the foot, the middle of the leg, and then the upper leg. Okay. And so the only exception here is the neck and the head, because there's only 2 sections here. Okay. Right. And so here's kind of how the numbering typically is. And so this numbering is fairly arbitrary, and so I wouldn't say that this is the most standard way. But what is pretty standard is kind of these first 3 right here, right? And if you notice, our numbering starts with the with kind of the middle section of our body, which is our torso and our pelvis, right? And this part is pretty intentional because you're a lot of terminology and a lot of concepts in biomechanics. We really consider the chest and the abdomen and the pelvis as that's kind of like the middle point of your body. That's kind of the point of reference. Okay. And the reasons for this are mostly is because it's the most center point of your body, and so it kind of serves as kind of a nice reference point. Usually it's the most stationary part of your body. If you compare it to how much you can move your arms and your legs, your torso stays relatively the same, right? And so it kind of serves as kind of a nice origin for your for your Cartesian axis. Okay. And if you consider like where the center of mass or the center of gravity of your body is, it's going to be in your torso, because that's kind of where the middle of everything is, right? And so oftentimes the torso or the middle of your body, that's going to be the reference point for a lot of other terminology, a lot of other concepts that we're going to cover in biomechanics. Okay. Okay, so I know this is kind of a lot to write down, and so are there any questions on this that I can answer so far? Okay. All right. Anything else I want to say here? I think that's it. Okay. And so that's kind of like the overall kind of how we break down the body. But of course, if you look at specific body parts, you can break that up into different sections as well, okay? And so some common ones are your hand, right? And so your hand has a lot of different bones associated with it. And so a lot of times we're going to break this down into all the different bones in your hand, okay? And another common one is your head, okay? Your head and your neck, okay? And so you can see here we have a different segment for each of the different spinal bones in your neck, okay? And so these are more useful if you want to do kind of a more specific analysis, right? And so if you're looking at a specific injury in your hand, like maybe an injury to one of the finger bones or one of the hand bones, something like this is going to be a lot more useful than a whole body model, right? And so there's a lot of such models that, like these that exist, and you just kind of have to just use the one that's more useful to you. But usually the starting point is this whole body modeling right here, which has kind of your entire body and each of the different segments that are labeled. Okay. All right, and so now let's go over a positional terminology. Okay. And so now that we know all the names of different major sections of the body, the next step is to learn, kind of some terminology for relative position or relative direction. Okay. And so this is really important because, once you have kind of identified the part of the body that you're talking about, you need a little bit more information or a little bit more terminology to describe a precise location. Okay. And so as an example, so let's say that you sustained a lower leg injury, when you're playing soccer or something like that. Okay. But your lower leg kind of encompasses, your entire shin, right? And so, if a paramedic comes or your sports doctor comes, and you're trying to describe which part of your leg is injured, you kind of have to, you can't just say lower leg, and so you have to say, whether it's in my ankle, whether it's superior to the ankle, where is it relative to your knee, and things like that. Okay, and so just describing where on your body things are located. There's a lot of terminology that's associated with this, okay? And so it can be really useful to use a Cartesian coordinate system for these kinds of things, okay? So Cartesian coordinate system is nothing more than just an XYZ axis, okay? And just as useful as it is to use to indicate positions in regular space, it's useful for the body too, okay? And this is especially useful when you're looking at medical image data for certain patients as well, okay? Because a lot of times they're going to be oriented in terms of X, Y, and Z axes, right? And so usually the X, Y, and Z axes themselves are oriented in the same direction for people, right? And so the X direction you can see here points forward, okay? And so that's the positive X direction points, in the forward direction. The positive Y direction points to the person's left, and you can see that from here, okay? And the positive Z direction points upwards. Okay, so this is kind of the standard orientation for these kinds of for these coordinate axes. Okay, and you can see them indicated on this kind of slender man looking dude right here. It looks like a crime scene. Okay. Okay, and so now that we know the kind of the principal axes of a person's body, now we can talk about the principal planes, right? And so if you consider the XYZ axes that we defined before, they're going to define three principal planes that we can talk about for a person's body, right? And each of the planes kind of is kind of the space spanned by two of the axes together, right? And so let's take the YZ plane, right? And so the YZ plane is kind of this plane right here that I'm kind of outlining with my mouse, okay? And you can see that if you kind of visualize that, that's kind of a plane that kind of runs between your shoulder blades, right? And so if you kind of draw a plane between your shoulder blades and kind of have the plane just like this, right? That's known as the coronal plane, right? And so the thing with the coronal plane is that it splits the body into two sections, right? And so it's going to split your body into a frontal section. So everything in front of the coronal plane will be the front section. And another term for front is anterior, okay? And then the other way that it splits your body is into a rear section, which is called the posterior section, okay? And so everything behind the coronal plane is called the posterior section, and everything in front is the anterior section, okay? All right. The next plane that I want to talk about is the XY plane, okay? And so the XY plane is kind of a plane that you can imagine, if you kind of think of the magic tricks where people saw, the magician saw someone in half, right? And so that plane where you would saw someone in half, that's the transverse plane, right? And so that's the XY plane that you can see from this figure right here. Right? And so And so the thing with the transverse plane is going to split the body into an upper section, which is everything above the transverse plane, and a lower section, which is everything below the transverse plane. Okay. All right, and so that's the transverse plane. And then the last plane that we'll talk about is the sagittal plane. And the sagittal plane kind of, runs right through your nose. So it's kind of something like this, right? And so the sagittal plane is gonna be your XZ plane, okay? And so it's the plane spanned by the X-axis and the Z-axis, and it splits your body into a left section and a right section, okay? And so that's relatively straightforward, right? And so these planes are really important because they in a lot of ways they kind of split your body midway in 3 different directions, okay? And so if you can locate a point in your body relative to these planes, usually that's a good way of defining position in your body. Okay. All right. Any questions on this so far?
Yes, I have a question.
Sure.
For the transverse plan, is it splitting the human body like midway in the torso, or is it depending on where the center of mass of that human body is, or how does it work?
Yeah, no, it's a good question. Yeah, so usually the origin of the coordinate system, it's placed at your center of mass. From this figure, it kind of looks like it's at his belly button, and so if you usually I just tell people that it's kind of where your belly button is. So kind of everything above your belly button, that's kind of the upper section of your body, and everything below your belly button is the lower section of your body. Yeah. Okay. Any other questions on this part, on the principal planes? Okay. All right, and so now let's talk about reference configurations, okay? And so what I've shown you here for the XYZ axis, you can kind of think of this as the global coordinate system, or kind of the the global coordinate axes for the person's body, okay? But a lot of times, especially if you're designing a device or you're talking about injury or of a certain body part, you're focused on just a single body part, okay? And so, it can be really useful to have reference, a local coordinate system, that's centered on each different body segment. Okay. And so if we look at this, Z8, Y8 right here, this is kind of a local coordinate system that's centered on just the head. Okay. And so, if you're talking about just a head injury, it could be useful to have this. And in the same way, you can have a local coordinate system for each of the different body parts of your body. Okay. All right. And so if you take all of these local coordinate axes and then you position your body in a way such that all of their axes are parallel, okay? And so you can see here that this is the case where you can see each of these Z's right here, right? Z8, Z9, Z3, all of them are parallel to each other. Same thing with the X and the Y axes, okay? When all of these are parallel, this is what's known as a reference configuration, okay? So this is kind of the person at rest, okay? So this is kind of a very fancy kind of mathematical way of saying, what's kind of like a resting position, okay? Because, for the human body, you can move it in all different kinds of different ways, but a lot of times it's useful to kind of have a position that comes as a reference. And so, if you move your arm, we can say that you move your arm in relative to this reference configuration, okay? And so this is really useful for doctors when they're studying motion or for when they're studying, injuries for people, because, they usually ask you to kind of stay in the reference configuration and then move from there, okay? And usually there's more than one. And so there's a standing reference configuration and a sitting one, okay? But again, this is just to kind of serve as a, as a reference for defining all the motion, okay? And it's really just kind of a way just to say, what's a position where, all your body parts are kind of in a nice configuration that we can begin analysis from, okay? Because another way to think of the human body is kind of as a really big mechanism or a really big machine, okay? And usually, when you think of like kinematics of machine, there's usually kind of one orientation or one position where it's kind of easy to kind of start your analysis from, and that's what the reference configuration is, okay? And so that's kind of what I mean when I refer to this, okay? All right. Okay, so now that we have an idea of what the reference configuration is, now let's talk about what happens when we kind of move away from this, okay? right? And so here's, there's a ton of terms on this slide, and so, it's going to be kind of a lot. But, these are terms that that doctors and, biomechanics use to describe, relative positions of certain body parts. Okay. All right. And so, I think this figure here does a pretty good job of it, but here are kind of all the 8 terms that we associate with this. Okay. And so if we want to say that something is above something else or something that's more towards the head, we say superior. Okay. And so one way that you can kind of, one example of this is, let's say that we want to talk about the relative position of the pelvis relative to the knee. Okay. And so what we say is that the pelvis is superior to the knee. Okay. That's not to say that the pelvis is better than the knee or in any way. It just means that it's closer to the head than the knee is. Okay. And so that's kind of a simple example using a big body part, but you can use this to describe where a certain injury is as before, right? And so let's go back to our example from before when you want to describe kind of a lower leg injury to a medic, right? And so instead of just saying that the injury takes place in your lower leg, what you can say is that the injury is inferior to the knee, but superior to the ankles. Okay. And so these terms are, they're used a lot to kind of describe, where certain things are. Okay. All right. And so let's go over what each of the different terms mean. And so if you say superior, what that means that it's going to be closer to the head or towards the head. Okay. Inferior means that it's closer to the feet. Okay. Anterior means towards the front of the body, and posterior means towards the back of the body. Okay. So I think those are relatively straightforward. Okay. Next, we have proximal. And so proximal means towards the torso, and then distal means away from the torso. Okay. And so a couple examples of these terms and actions is let's say that you have an injury to your arm. Okay. And so you can say that, and you're trying to describe where the injury is on your arm. You can say that I have an injury distal to the elbow. Okay. And so if you say that, that means that it's, your injury is going to be somewhere over here. Okay. Because your elbow is right here. And if you move away from the torso, it's going to be towards your forearm. Okay. And same thing for proximal. Okay. Next, we have medial. And so when you say medial, that means it's going to be towards the midline of your of the body. Okay. Or in other words, towards the sagittal plane of your body. Right. And then lastly, we have lateral. And what lateral means is it's moving away from the midline. Okay. And so, these terms are often used to describe movement. Okay. And so if you kind of take your arm and you kind of move it kind of like this, like kind of raise your arm. Okay. What you're saying is that another way to say that is you can say that your arm is moving laterally away from your body because you're moving it away from the midline. Okay. Right. And so, these terms we'll use quite a lot in this class. And so, I know it'll be a little bit disorienting at first, but as you start to use it more and more, you'll get more used to it. Okay. All right. So any questions on this so far?
So when you're speaking about distal and what's it called? Are you picturing your body as if you were like laid down like a starfish situation?
Yeah, no, I think that's a good way to think about it. It doesn't have to be in that starfish position, but I think that's the easiest way to visualize it. Because if you're in a starfish, things that are away, you can see very easily, what's distal from your torso and what's proximal to your torso. So yeah, that's a good way of thinking about it. But the same terms will still apply, even if you're kind of standing still. And so even
just like to picture it though, like that's kind of where it is.
Yeah.
Like it doesn't change obviously, like depending on like how you're sitting or standing, but like to know where things are kind of.
Yeah. No, yeah,
Okay.
I think that's a great way to think about it. Yeah. So if you think of a person kind of splayed out in a starfish position, that's a good way to think about proximal and distal. Yeah.
Okay. Thank you.
Okay. All right. And so that's positional terminology. And so now let's talk about movement terminology, right? And so, there's a lot of different terms to describe movement. Okay. And so the most common type of movement that you see in the body is flexion. Okay. And so flexion is any kind of bending motion that kind of brings, something closer, brings a body part closer to another one, okay? And so as an example, if you take your arm and you kind of bend it towards your elbow, okay? That's called flexion, okay? And so that's, bringing the body part closer to you, okay? And so same thing for your knee. And so for your knee, when you flex your knee, you're bringing your heel closer to your butt, basically, okay? Right. And so the opposite of flexion is extension. Okay. And so when you're extending something, you're kind of putting your body part kind of in a longer orientation. Okay. Or in other words, you're taking your limb and you're straightening it out. Okay. Right. And so here's some kind of images that kind of illustrate that for you. And so on the left right here, you can see for the knee. Okay. And so you have flexion at the knee. You can see you're going to bring your heel up. But then extension, you're going to be straightening your leg out, and then same thing for your, same thing for your elbow. Okay. I think the one that kind of confuses people a little bit is the head, right? Because if you move your head kind of back and forth like this, you can argue that it's, when you're flexing, you're also kind of extending because it's, you're bringing your neck closer, farther away from the back. But that this is kind of the terminology that we have for that. So flexion means to bring your chin closer to your chest. And then extension means to kind of straighten it out that way, okay? And so, I'll make a note here because for engineers, this can be a little bit confusing because, when engineers say that we extend something, usually we mean that we're elongating it, right? And so if you're extending a beam or extending a wire, that means you're kind of pulling it and making it longer, okay? But it doesn't have that same kind of definition in biomechanics. So in biomechanics, when we say extending, all we basically mean is that it's just straightening out. Okay. And so we're not actually stretching it. We're not actually, pulling it like this. All we're talking about is just making the limb, straightening out. But the limb itself is not growing in length. Okay. All right. Any questions on this? Okay. All right, and so that's kind of the basics for movement terminology. And so flexion and extension can be used for a lot of different muscles. Okay, but there's other movement terminologies as well. Okay, and so you have ones that are like lateral bending. Okay, remember moving laterally means that you're moving away from the midpoint. Okay, and so if you tilt your head to the left, you tilt your head to the right. That's known as lateral bending because it's you're moving away from the midline. Okay. Next, we have rotation, which rotation all it means is that you're kind of rotating your body on a swivel, okay, or rotating the joint. Okay. And we also have supination, and so supination all it means is that you're kind of turning the limb upwards, okay. And so supination mostly just refers to the arm, okay. And so the way I like to think about it is if you're supinating, you're kind of opening up your wrist like this, so that if you want to hold the bowl of soup, then that's what you're doing, okay. And so you're opening up your palm in order to place a bowl of soup in your hand, okay? And then the opposite of supination is pronation, where you kind of turn your wrist kind of down towards the ground, okay? All right, and so here's the ones that I always get confused about, okay? And so there's adduction, okay? And so adduction means to bring something closer to your body, okay? And then abduction means to pull it further away, okay? And so the way I kind of remember this is that I focus on the add in adduction, okay? And so when you bring you bring your leg closer to your body like this, you're kind of adding to your to the mass of your body, right? And so you're kind of adding stability because you're coming back in, you're adding weight here, okay? Abduction is the opposite of that, and so you're kind of bringing your limb kind of away from your body, okay? All right. And so these ones are a little bit further, a little bit more difficult to see, but they refer to kind of the position of your heels, okay? And so varus, what that means is that you're bringing your heels closer together, bringing your heels and your legs you're kind of twisting it in a way to bring them closer together. And so you can see here that the legs are pretty close, okay? Whereas valgus, you're kind of bringing the heels further apart to kind of make the knees and the legs further apart like that, okay? Right, and so now we have more movement terminology for the feet, okay? First, we have plantar flexion. So plantar flexion, all that means is you're kind of bending your foot towards the ground, okay? And then dorsiflexion means you're kind of pushing your feet further up, okay? And so the way I kind of remember this one is that plantar flexion means that you're you're planting your foot into the ground, okay? And so that's where the plant comes from. And then dorsiflexion, you're kind of making like a dorsal fin, like on a dolphin, right? And so all the dolphins and have that fin that's on top, right? And so when you kind of bring your foot up, you kind of make that kind of same kind of fin, fin motion, right? And so that's how I remember those ones. Okay. Next, we have kind of the left and right bending of your ankles. Okay. And so first we have eversion, which means that your ankles are kind of bending inward like this. And so they're kind of making a V. Okay. And then you have inversion, which is the opposite motion, where your ankles kind of turn up and make kind of an upside down V. Okay. And so inversion is typically how people sprain their ankles. And actually a couple weeks ago, I sprained my ankle doing just this actually. I was playing ultimate frisbee and I kind of, I stepped on a dirt patch and it kind of twisted my ankles that way. So yeah, usually you don't want to be twisting your ankles too much because as we'll see later on in the semester, the ankle is a pretty unstable joint actually. And so a lot of sports injuries occur at the ankle joint. Okay. Okay, so any questions on this so far? Oh yeah, rolled ankles is extremely common. Yeah, so anytime you do any kind of active activity like hiking or sports or anything like that, so rolled ankles I think might be one of the most common injuries that are out there. Yeah. Okay, let's go ahead and move on. All right. And so that's, I know that was kind of a blitz course and a bunch of positional and movement terminology, right? And so I know it's going to take a while to understand all that, right? So now let's get into the names of the different bones and the different muscles, okay? And so I don't want to get too much into this right now because it's, we're going to go over this a lot more in detail later on this semester when we start focusing on certain body parts. But I at least want you to know some of the major bones, okay? And so the purpose of the bones is to basically provide the main structural strength for your body, okay? And so your bones are the ones that give you kind of, structure, right? So they make sure that you don't just disintegrate into a pile of poop, right? And so the fact that you can actually have some structure and actually pick things up is thanks to your bones, okay? And each of your bones has a name, right? Unfortunately, they're not very. The names are a little bit hard to remember because biologists are too good for arm bone and leg bone. They have to give things like words like clavicle and humerus and things like that. And so, we're not going to get into this yet, but just kind of know that these are kind of the names that are out there. Okay. But one bone I think is really nice to know, especially because it's kind of it has a really nice geometry, is the femur, which is your thigh bone. Okay. And so the thigh bone is the longest bone in your body, or the largest one. Okay. And then the next largest bones are going to be your humerus, which is your upper arm bone, and then your tibia, which is the big bone in your lower leg. Okay. All right. And so these are kind of the major bone groups. This is not every single bone in your body. They're each, believe it or not, each individual rib and each individual, finger bone has its own name. But I think this is usually a good starting point. Okay. And so let's start in the middle here. And so first we have the bone that's kind of in the middle of your ribs, and that's known as the sternum. Okay. Next we have this kind of thin bone here that connects on top of your shoulders called the clavicle. Okay. And so you can actually feel your clavicle, on your body. So if you kind of run your fingers kind of down your neck, eventually you'll kind of reach this bone that's kind of fairly exposed actually, and it kind of runs from your ribs over to your shoulder. Okay. Clavicle injuries are extremely common because it's a bone that's really exposed compared to a lot of your other bones. Okay, and so any kind of impact that you have on your chest, it's likely to cause a clavicle fracture because it is very exposed. Okay, it's not shown here, but you have kind of a bone kind of on the back of your shoulder that kind of looks like a shoulder pad called a scapula. Okay, and so that's kind of behind here. Okay, your humerus is the bone of your upper arm. Okay. Your radius and your ulna are the two bones in your forearm. Okay. The ilium is your pelvic bone. Okay. We already went over the femur, which is your thigh bone. The patella is your kneecap, and then the fibia and the tibia are your kind of the major bones in your lower leg. Okay. And so again, I'm not expecting you to know all of these terms right now, but just kind of be aware of this. And then once we start going over each of the body parts kind of in more detail, we'll be coming back to this and using these terms for the bones. Okay. Okay, so any questions on skeletal anatomy?
Yeah, Professor, I'm having a hard time seeing on this diagram. Is the tibia in the front and the fibula is in the back?
Yes, yeah, the tibia is in the front and the fibula is in the back. Yeah, the tibia is the bigger one. Yeah, there's much better figures online, but this is one that kind of just fit on my slide. Yeah. All right, question: do we have to remember all these by the end of the class? Absolutely not. And so honestly, I'm probably going to forget half of these at the end of the class, because it's, these terms are hard, and there's a lot of terms out there. But again, I just want you to be kind of aware of some of these names, and just to kind of start getting used to the terminology. And then once we start going through each of the different body parts in more detail, that's when these names will be a lot more useful. But yeah, you don't have to memorize these at all. But the reason I kind of deliver these lecture notes as slides is so that I can have figures like this where you can kind of look back and refer to. Okay. Usually I don't like doing this. Usually I don't like doing lecture slides, because I feel like it's less interactive than writing. But when there is a lot of figures and a lot of things where it's hard for me to draw, that's usually when I use lecture slides. And so I have these slides, and I gave them to you on purpose so that you can look back and refer to these as possible. Okay. And so you can think of this lecture, this particular lecture, as I'm kind of introducing a lot of these concepts to you, and a lot of these names. And then as we go through the semester, kind of always keep these PowerPoint slides on tab. And so you can say that, oh, what's the name of the thigh bone? And you can say, oh, it's the femur, right? And so use these slides. I think of these slides as more of like a reference that you're going to use throughout the semester. And then for now, I'm just kind of introducing, just kind of very briefly, everything to you. Yeah. All right. All right, and so let's talk about a little bit of the structure of the long bones. And so we'll be going over this in a lot more detail in about 4 weeks when we talk about bones in more detail. Okay. But I at least want to talk to you about, a little bit of how your bones are structured. Okay. And so, the reality is, there's no one bone structure, because, all the different bones in your body are different. They're different sizes and shapes, but they have some similar they have some similar features. Okay. And so particular, I want to look at long bones, which are the bones that kind of comprise a lot of your limbs, right? And so the bones in your arms, the bone in your legs, right? And so these are what a lot of these bones look like, okay? And so generally these bones tend to be cylindrical in shape, okay? And so they have kind of a long shaft portion, okay? And then at the ends, they kind of have a rounded part, or a bigger rounded end, okay? And then the technical terms for the shaft is the diaphysis. And then for the rounded ends, those are called epiphysis, right? But you'll probably, most likely, you'll hear me call them the shaft and the round parts. Okay. Okay. And so your bone actually isn't all just one hard material. So actually, on the outside of the shaft is a very hard, kind of exterior, right? And so this is called the the compact bone. Okay. Whereas inside of your bones, it's actually a lot more soft and spongy. Okay. And so, those two kind of combine to kind of give your bone its structure. Okay. And so at its core, you can almost think of a bone as kind of like a composite material, right? And so it's not all the same material all throughout, right? And so it has a very hard exterior, and that's to kind of protect you against blunt impacts, right? And so if you punch your bone, you're punching kind of the hard exterior of your bone, and so it doesn't crack, or it doesn't bend like that. Okay. But believe it or not, actually the soft, spongy interior is actually really important too, because it might not seem like it, but your bones, there's some flexibility in your bones, believe it or not, right? And that's really important, because you don't want your bones to be too brittle, right? And so if you think of material, if you think back to your strength of materials class, that a brittle material is usually not something good to make a structure out of, right? And so you wouldn't make a car frame, or you wouldn't make a building out of something brittle, right? And so even though a brittle material might be really strong, what you know about brittle material is that once it starts to strain a little bit, and then the whole thing just kind of falls apart, right? And so it might be really strong initially, but once it fails, it kind of fails really spectacularly, right? And so you don't want that for your bones. If you want your bones to actually have a little bit of give in it, a little bit of play, and so that when it does sustain some kind of external force, it has some capability to bend a little bit before it just completely breaks. Because if it completely breaks, then you're screwed. Okay. And so that soft, spongy bone on the interior is actually really important for the bone in order to keep its structure. And another purpose for the spongy interior is to keep it light as well. Okay. And that's really important so that you can move your limbs really efficiently. Okay. All right, and so the rounded parts or the epiphysis of the bones, these are mostly just to serve as attachment points. Okay, because your bones are connected to muscles and they're connected to other bones, right? And so the reason we have kind of a bigger rounded sections on the ends of your bones is to give kind of more surface area to attach to these things. Okay. And so some examples of things that attach to bones are ligaments. Okay, and so ligaments are a type of cartilage that connects your bones to other bones. Okay, and so what connects your your arm bone to another arm bone is a kind of almost like a fiber, almost like a wire called a ligament. Okay, and another type of cartilage that your body has is called tendons. Okay, and so tendons connect your bones to the muscles. Okay, and so when your muscle contracts and it pulls your bone in a certain way, the way that the force from the muscles transmits to the bones is through the tendons. Okay, and your bone's going to have these kind of larger areas where so it has space for all the ligaments and the tendons to attach. Okay. All right. So any questions on long bone structure? All right. Question. So are they running through the bones? Are you talking about the ligaments and the tendons? No, so those just attach on the outside, and so those so if you think of if you kind of ball up your fist and think that this is kind of an epiphysis for your bone, and so a ligament will just kind of attach right there, and so it's basically, you can almost think of it like it's glued or it's taped to the ends of the bones, but they don't run all through the bone. Yeah. Okay. And so let's talk about the skull anatomy for a little bit, although I don't want to spend too much time because we're almost out of time. And so your skull actually is not one big bone. And so actually it's a collection of a bunch of different bones that are knitted together. Okay. And your skull bones actually don't have the same structure as the long bones, right? And so you can, obviously your skull is not a cylinder, and none of these things are. Okay. But your skull is actually a collection of all these different different plates. You can kind of think of it like that. Okay. All right, so let's talk about the spine. And so the spine is one of the most important bones in your body, right? So first of all, it houses the major nerve that goes through your body, right? And so that's kind of how your brain communicates to all the muscles. Okay. But it also provides, it's kind of the it's literally the backbone of your body. So it provides it's kind of the main supporting structure of your torso, right? And so your spine is basically the same thing as like the columns in a building, right? And so the columns are the things that are bearing most of the weight. Those are the things that kind of provides the most structural integrity to the building, right? And your spine kind of serves the same purpose, okay? And so your spine is split up into 4 different parts. And so we have the cervical spine, which is the section of the spine that's in your neck, okay? Next, we have the thoracic spine, which is the section of spine that covers your chest. Okay. Next, you have the lumbar spine. And so the lumbar spine is kind of the section of the spine in your lower back, kind of right above your butt. And then you have the sacrum, which is your tailbones, which is kind of the very end of the spine, which you can see right here. Okay. Right. And so your spine has a very unique structure because it's not just one bone. It's actually a bunch of these little vertebrate bones that are stacked on top of each other. Okay, and they kind of move kind of like a they kind of almost look like a zipper almost, but they're designed in such a way that that they can take a lot of impact, they can take a lot of punishment, but still give your back some flexibility too, right? And so it's not, you don't just have a rigid rod in your back, because if you can imagine, if your spine was just one long bone, you wouldn't be able to move your back, you'd just be kind of stuck like that, right? But the fact that your vertebrates are kind of stacked on top of each other, and there's some play in how they can move, that kind of gives your back the flexibility to kind of move and adjust the way that you need to. Okay, while still providing a lot of the a lot of the strength and the structure and the for your torso and the rest of your body. Okay. Okay, so are there any questions on this so far? Okay. Yeah, your spine is a very important part of your body, and so we'll have a week that we dedicate to just the spinal anatomy, the spinal structure, and all the different kinds of engineering devices and stuff that supports the spine, because it's it's kind of the first thing to go when you injure yourself, right? And so it's really important. Okay. All right, so let's talk about joints. And so joints are basically the intersection between two major segments of the body, right? And so you remember, from the beginning of class where we broke up the body into each of those, different ovals, right? The way that we broke them up is through the major joints, okay? And so joints basically allow a certain type of movement of different body segments relative to each other, okay? And so they're basically the same as a joint in a mechanical machine, right? And so you can kind of think of them as the same way. And so there's three different types of joints that we typically have in the body, right? And so first is a hinge joint. And so a hinge joint basically only allows one rotational degree of freedom, okay? And so an example of this is your elbow, right? As your elbow basically it can just flex on this hinge, right? And so if you put a hinge on your elbow, right, it'll basically only allow your elbow to kind of flex like this, okay? No, it's just for the motion. It's I know if you look at my arm, it's very gelatinous because I haven't worked out in a long time. Okay, and so the next type of joint is a slider joint. And so a slider joint, probably as you know from mechanisms, it only allows one translational degree of freedom. Okay, and so a slider joint doesn't allow any rotation. It just allows kind of something to go in and go out. Okay. And so it's not actually that common in your body, but kind of the place where you see it the most is between a bunch of the small bones in your hand. Okay, and so in your hand, not your fingers are hinged because they can rotate, but inside your hand you have a bunch of these small bones that can kind of move and translate relative to each other, right? And so those are the slider joints. Okay. And then the last type of joint that we have in our body is called a ball and socket. And so this allows for the most degree of freedom, okay? And so your shoulder joint is probably the most famous ball and socket joint in your body, but also the joint between your thigh and your pelvis is also ball and socket, okay? And so the thing with ball and socket joints is that it allows for, three rotational degrees of freedom. And so you can do, all different kinds of motion with your ball and socket joints, okay? And geometrically, what they look like is they have kind of one sphere head and then another kind of another part which kind of wraps around the sphere. And so the sphere can kind of rotate inside that joint freely as it can. Okay. Okay. And so what I have on the right here, these are kind of the mechanical representations of each of these different joints, right? And so if you were to build a mechanism with the hinge, this is what it would look like. Okay. But in the human body, your joints don't exactly match up like this because human anatomy is kind of weird. It doesn't have these exact shapes. And so when we characterize a joint as a certain type, it's only really an approximation. Okay. And so in reality, a lot of joints can be kind of part ball and socket or part hinge or mostly ball and socket and part slider and things like that. And so these classifications are only kind of only approximations, whereas kind of the real motion at these joints can be a lot more complex and can kind of not really fit into these categories exactly. Okay. Okay. So any questions on this so far? Okay. All right, and so let's talk about the major muscle groups. Okay, and so the muscle groups. This is something that we'll really kind of table for later, but I at least want to expose you guys to a little bit of the muscles. Okay, and so muscles are the only organs in your body that can kind of provide motion. Okay, and so there's in reality there's three types of muscles, and so there's cardiac muscles, And so these are the muscles that are inside your heart, okay? And they basically pump your heart and pump all the blood, right? And so, your cardiac muscles can't be directly controlled. And so, they're controlled, by your brain. And it's basically programmed to just keep pumping, okay? But they do respond to certain things, right? And so if you start getting stressed, you start getting nervous, you know that your heart rate kind of goes up, right? Or when you're sleeping, your heart rate tends to go down, right? And so your cardiac muscles, they do respond to certain things, but they're not, but they're not voluntarily controlled by you, okay? All right, and so the next type of muscle is a smooth muscle. And so your smooth muscles are the muscles that line your internal organs, okay? And so if you think about, the muscles in your esophagus, right? And so when you swallow something, there's muscles that kind of push the food down to your stomach, okay? And so any kind of muscle that lines an internal organ, that's a smooth muscle, okay? And again, these can't be directly controlled by you. Like you can't tell your intestines to push, right? That's kind of something that's controlled by your body, but it's there, okay? And so, we won't really consider cardiac muscles or smooth muscles in this class, but what we will be focusing on are skeletal muscles, right? And so skeletal muscles these are the muscles that connect your bones, to each other, and these are the ones that cause, movement of the human frame, right? And so these are the ones that can be voluntarily controlled. And so, what we'll focus on in this class is just purely skeletal muscles, right? But just be aware that, the other two types of muscles exist. It's just they're not going to be the subject of this class, okay? All right, and so the thing about muscles is that they can contract, and so your muscles can, shorten, and that's kind of how they produce motion, is that they kind of contract on itself and kind of shorten in length, and that pulls, a certain body part towards each other, okay? But contrary to, what some people would believe, your muscles by themselves can't extend, okay? And so once a muscle contracts, it can't extend by itself, like it can't push itself further, okay? And so in order for a muscle to actually extend and get longer, the way that it does that is by the contraction of by an opposing muscle, right? And so let's take your bicep as an example, right? And so when you contract your bicep, your bicep muscle gets shorter, right? You can see my muscle here gets shorter, right? But in order to extend this bicep muscle, what's actually happening is that my tricep muscle is kind of pulling my arm from the back, right? And so, you can see kind of my arm here that's kind of pinching this muscle, right? And so by my triceps contracting here, that extends my bicep, okay? And so most muscles in your body, especially the ones at your hinge joints, they appear in pairs, right? And so when one muscle group contracts, the other one extends, and then when the other one contracts, then the first one extends as well, okay? And so just remember that, muscles, they have no way to extend itself. They can only contract, right? And the only way a muscle can extend is by, an opposing muscle group contracting at the same time, okay? Okay, so any questions on this? Right. And so again, with these names here, it's these aren't, I'm not going to expect you to know these by the end of class, but just kind of be aware of these kind of terminology, right? And yes, I know that there's a but here. Yeah, I'm aware of that. Okay. And so the last thing I want to go over today is a concept known as anthropomorphic data, right? And so, ideally what we'd like to do in this class, and as engineers is, we'd like to design certain devices for certain parts of the body, right? But as you know, if you're designing something for another engineering system, like say like a building or a car, you need to have some idea of how big or what the dimensions of your part is, right? And so if you're designing something for, a 3-story building, you need to know how tall that building is going to be, how wide it's going to be, right? And so same thing for the human body, right? And so if you want to design something for the human body, you need to have some sense of, how big it's going to be, what the measurements are going to be, okay? And so any kind of geometrical data, any kinds of lengths or sizes or surface areas or volumes, we usually refer to this as anthropomorphic data, okay? Excuse me. And Usually the way that these are defined are, by these measurements on the right here, right? And so everyone kind of has these sets of measurements right here, which is, like measurement A here is the stature, which is, how just basically how tall you are, okay? Another measurement is how tall your eyes are, right? And so next would be how tall your shoulders are. Okay? Next is how tall your height, your waist is, and next is how tall your butt is, right? And so for each person, each of these measurements are going to be different, okay? And then you can also have measurements for, what your sitting height is, what your eye height is when you're sitting, all these different things, okay? And of course, for each different person, these numbers can vary tremendously, okay? And so, if you want to design something for a certain person, it helps to have these measurements exactly, right? And so if you're getting a suit tailored to you, that they take all these measurements that they can make the suit fit exactly for you, okay? But a lot of times, it's okay to just kind of design things for the average, okay? And so it's useful, to have kind of average numbers for these data, okay? And that's what I have on the next page right here, right? And so, what you can see here in this table is you can see kind of the, what dimension that we're looking at. And so if we look at the first row of this table, we can see that, we can have measurements for the height of a person, okay? And you can see here that this is broken down between male and female, and what the 5th percentile is, the bottom 5th, what the 50th percentile or what the average person is, and what the 95th percentile is, okay? And I believe these measurements here are in meters, okay? And so the average human height is about 1.76 meters, okay? And so that's the 50th percentile. And so if you're in the 95th percentile, or if you're taller than 95% of people, then you're going to be about 1.87 meters tall, okay, for a male. And if you're the bottom 5%, which is probably me, because I'm pretty short, you're going to be about 1.65 meters tall, okay? You're 25%. I see. Right, oops. Okay. And we have, the same similar measurements for each of the different, measurements here. So the eye height, the shoulder height, waist height, butt height, and things like that. Okay. And so this data like this, this is not the only data that's out there. And actually, I think this might be a little bit out of date because I took it from the textbook, which is about 10 years old now. And so, if you want to get kind of average data for these kinds of things, just search up, average anthropomorphic data, and you can find those measurements online. Okay. And so if you're designing some kind of device and you want to just have kind of a reference size, then looking up tables on anthropomorphic data is probably kind of a good place to start. Okay. And so let's say that you work for a company that's designing bulletproof vests, right? And you want to basically design the vest so that it's basically the size between B and C. Okay. And so one starting point that you can do is you can take the difference of B and C. So you can do, let's say that the 50th percentile here. And so if you the difference between C and D, right? So because we want something that goes from your shoulder to your waist, okay? And so if you subtract C and D here for the average person, we do 1.44 meters minus 1.102 meters, okay? And then that'll give you kind of a starting point for how you design kind of the height of your vest, okay? And so of course, it's not going to work for everyone because this is, for the average person. And if you try to put it on someone like me, it's going to be a bit too big. But it's a good starting point, right? And so, a lot of times, you're gonna be designing devices, and you're going to be designing equipment that's more specific to a certain crowd. But if you need a starting point, anthropomorphic data is a good place to start. Okay. Right. And so here's some of the other measurements. Okay. I think. Oh, actually. Yeah, so I think these are in meters, and I think these must be in inches. I think, yeah. So I think this is the same information, but just in different dimensions. Yeah, I should have put the dimensions on these, but I'm pretty sure these are in inches, and then these are in meters right here. Okay. Okay. So any questions on this before we wrap up for today? Okay. All right, and so that's all I had planned for today. So thank you guys again for meeting virtually. I know it's kind of been an awkward start to the semester, but I appreciate you guys being flexible. And then, hopefully I should be able to get my test results by next week. And so within the next couple of days, I'll let you know what class is going to be like next week, right? And so thank you guys for tuning in today. And I hope you guys have a great weekend. I hope you guys have a good first week of class. And I'll see you guys next week.
Have a good one, Professor. Hope
Thanks,
you
you
feel
too.
better.
Thanks, guys. Thank you so much. Thanks, you too. Fee, did you have any more questions? Okay. All right, so I'm going to close the call and then the recording will be up later. So have a good weekend.